integration of exact differentials. This is how you solve exact differential. That means you want to find z. If you have dz equals to p dx plus q dy, you're trying to find z. But p is partial derivative of z with respect to x, and q is partial derivative of z with respect to y. So I can write this partial equation by multiplying both sides by dz, partial z, and transforming into differentials. dz equal to p dx. Now I need to integrate both sides. That's an integration sign, which means we're summing them all up. And if there's nothing here, it means there's 1. So that's that 1. Just like here, there's p. We need to integrate with respect to z, which means I have to put z here to power 0 because I'm doing z integration, and z to power 0 is 1. If that was t, I will put t to power 0. If that was x, I'll put x to power 0 to get 1. Anything to power 0 is 1, which equals to integral of p dx. So that's an integration sign. And to integrate that, z to power 0, this is integration process. N is 0, so I put z to power 0 plus 1, that's 1, over 0 plus 1, that's 1. So the answer will be z. So we get z equal to integral of p dx. So that's one way of solving this, and that's how you find z. We can also find z another way by using q, this one here, and multiply both sides by partial y, and we write it into differential. dz equals q dy. And then we integrate both sides. Again, there's 1 here, so that means it's z to power 0, and then we get z. So we follow the same process here, and that equal to integral of q dy. So when we use both of them, we can then find a constant. Here's an example. We need to find z by integrating an exact equation. We can see that this is p, and that's p, and that's q. So for p, I'm going to write the integral form for that, which is integral of p dx. And so I'm going to plug in those values here. So that, I just put them here. And I need to distribute the integration sign across. Integral of 2xy dx plus integral of 6x dx. I'm integrating with respect to x. Y will be a constant. So I'm going to take y and 2 out because 2 is also a constant. And I'll rewrite integral of x dx. X is left. I'm integrating with x dx. 6 is a constant. So I take 6 out. I have integral x dx. This is my integration sign. X to power n can be written as x to power n plus 1 over n plus 1 plus c. So I'm going to do that here. This is the x to power 1, and that's x to power 1. And that will become 2y, x to power 1 plus 1, that's 2 divided by 1 plus 1, plus 6x squared over 2, plus, now I'm going to write a constant here. This is the important bit. That constant is in terms of y, because y is a constant here. So if we differentiate y with respect to x, then it will disappear. So that's why we have to write that with respect to y, and we call that ay. That 2, we cancel that 2. And the 2 we cancel 6 here to get 3. So we get z to be equal to x squared y plus 3x squared plus ay. So that's the solution, but we need to find ay to complete the solution. Now we need to find z in terms of q, and this is q, which is this one here. And so we write z equal to integral of q dy. And so we need to put this q here, and that's the q there. And we need to distribute the integral across. So we get integral of x squared dy plus integral of 2y cubed dy. There is no y here. X squared will be a constant, so we take it out. And then we're going to get 1 dy. That's x squared integral of 1 dy plus 2y cubed dy, because 2 is a constant. So we take 2 out as well. Now to integrate this, that would be y to power 0. X squared, y to power 0, because I'm integrating with respect to y, so I have to put y to power 0. Anything to power 0 is 1, plus 2y to power 3 dy. Now if I integrate that, y to power 0 will give me y 0 plus 1, that's 1, y to power 1 over 0 plus 1. And that should be y from that, plus 2y to power 4 over 4, because that's 4, that's 3. That'll be 3 plus 1, that's 4, 3 plus 1, 4. And there's a 2 here already, plus a constant in terms of x, not y, in terms of x. So that would be bx. And now this is z in terms of q. Z equals to x squared y plus y to power 4 over 2 plus bx, the constant. Okay, so we found z from p, we found z from there, and then we also found z from integral of q dy, where we found z. Now we need to find a and b. And if you look at this equation here, that and that we cancel out. We want ay would be that. So that would be ay because it's only in terms of y. And bx will be that because it's only in terms of x. If I differentiate this in terms of y, this will disappear. If I differentiate this in terms of x, this will disappear. So I can write this equation in terms of either ay and then replace ay with that, or I can write it in terms of bx and I'll replace bx with that. So I'm writing z equal to xy squared, which is common to them, plus, well, in terms of z here, I'll write 3x squared plus, instead of ay, I'll write y to the power 4 over 2. And that's the solution for the z. Here's an exercise. Pause and try solve for z for question 1 and 2. For question 1, here's the solution. And for question 2, here's the solution.